Okay, 7th grade is starting. 6.2.1 today, and it's called What Values Make Expressions Equal. And I'm going to go and read the intro. It says, in the last section you figured out how to determine what values of x make one expression greater than another. In this lesson you will study what can be learned about x when two expressions are equal. As you work today, focus on these questions. What if both sides are equal? Is there more than one way to simplify? What value or values of x will make the expressions equal? So we're getting through 3 problems today. The first one is 6-48. And it says, choosing a price plan. Sandeep works at a bowling alley that currently charges players $3 to rent shoes and $4 per game. However, his boss is thinking about charging $11 to rent shoes and $2 per game. Part A. If a customer rents shoes and plays 2 games, will he or she pay more with the current price plan or the new price plan? Show how you know. So Sandeep's bowling alley currently, I'm going to put the current, is $3 for shoes and $4 per game. The new one his boss is thinking about is $11 for the shoes and $2 per game. So there's our information. So now it gives us, for part A, it gives us how many games that we need to figure out the total price for. So let's do the current pricing plan first. So if we do $4 per, how many games? 2 games. So I'm going to multiply that by 2 and then add the shoe charge on top of that, which is 3. And you're not going to pay more than $3 for shoes because it's just a flat rate. So we have $4 per 2 games plus 3 extra for shoes, and that's going to be 8 plus 3, which is $11 total. Okay, so that's for part A for the current game. For the new game the boss is looking at, we are going to plug in different numbers because he wants $2 per game. So if he wants $2 per game, and we're looking at 2 games, and the extra $11 he wants for shoes. And we're going to solve it just like we did for the first one. So we have 2 times 2 is 4, plus 11, that gives us $15. So it says, will he or she pay more with the current price plan or the new price plan? So it looks like they will pay more with the new price plan, $15. The other one's cheaper. Part B. If the customer bowls 7 games, which price plan is cheaper? So we're going to do the same thing we did for part A, but instead of the number 2, we're going to plug in 7 where that 2 is. Okay, so let's do the current pricing plan, which is 4 times 7, and then add 3. So 4 times 7 is 28, plus 3 gives us $31. And for the new pricing plan, $2 per game, 7 games total, plus $3 for shoes. 2 times 7 is 14, plus 3 gives us 17. Oh my gosh, I did that wrong. Yay, where's my eraser? I accidentally put 3. Don't do what I just did. That one is 11 for shoes, not 3. 14 plus 11 is, 25. So for part B, which price plan is cheaper? Looks like the new price plan is cheaper than the current one. Okay, so that's your answers for part A and B of 6-48. make sure you're trying these first and then watching the video, because we want to try them out first and try to solve them ourselves before watching me do them. Okay, so 649 is next. And it says, will they ever be equal? So Sandeep decided to represent the two price plans from the previous problem with these expressions, where X represents the number of games. So here is the original price that is written down there. And he put the expression 4X plus 3. And the new price, the expression he wrote was 2X plus 11. And it also shows it on the expression comparison mat, which is in your book on the right-hand side. And it says for part A, are his expressions correct? Find both the original and new prices when X equals 2, and then again when X equals 7. So we're just trying to see if these expressions that he wrote give us the same answers as 6-48 when we plugged them in without the expressions, but we kind of did the same thing. So we're just double checking here. So let's plug in 2 for both of them really quick. So it says X equals 2. When X equals 2, let's plug it in there. 4 times 2 plus 3, which is 8 plus 3, which is 11. And then let's plug it in here. 2 times 2 plus 11 is 15. So that works. And then if X equals 7, we're going to double check. 4 times 7 plus 3, 28 plus 3 is 31. And then the last one is 2 times 7 plus 11, which is 25. So for part A, it looks good. We got the same prices that we found in the last problem. So that's part A. So those expressions work. Part B says, Sandeep then simplified the expressions on the mat. What steps did Sandeep take to simplify the mat to this point? So what I'm going to do here is I'm going to put a B, and I'm going to think about, I am going to quickly write down this expression mat, quickly as I can. So we have 4X's, and I'm not writing it exactly as I see it, I'm just writing it down quickly for sake of time. So there's X, 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 and then on the other side we have 2 X's, and we have 11 cubes. 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that was the original mat. These are all positive numbers. There's no negatives here, so I'm not going to shade in anything. So then for part B, he gives you a new mat, and I'm going to put this one in red to differentiate. And we're going to see what he did to get his new mat. So we have an X here, an X here, and then we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So you need to look at this one first, and then look at this one, and see what's different about them. So what I'm noticing is some X's disappeared here. So I put on my paper that he first matched up 2 X's from each side. So I see 2 X's and 2 X's can be crossed out because they're a matching set. So bye-bye, 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 bye-bye. And then he matched 3 1s from each side, and these are the little ones. So we can take away 3 of these and 3 of these. And that, I believe, is all that he did, because now he's left with 2 X's, and he's left with 1, 2, 3, 4, 5, 6, 7, 8 on mat B. So for part B, if you just want to write, if you wrote down the expression mats and just crossed them out, that's fine. But if you want to write it down, I put he first matched up 2 X's from each side, comma, then he matched 3 1s from each side. All right, I don't want to erase it yet, I don't think. Yeah, I can. I'm gonna erase it. So I don't think we need it anymore. All right, part C. Sandeep noticed that for a certain number of games, customers would pay the same amount no matter which price plan his boss used. That is, he found a value of X that will make 4X plus 3 equal to 2X plus 11. How many games would that customer bowl? What was the price he paid? And explain. I think this is the first time we've ever combined expressions with an equal sign without the mat. So what I want you to pretend is that we have like, this would be mat A and that would be mat B. Same rules apply, but we're just not drawing them. We have them in symbol form. All right, so what I can do first is we can start matching up the X's, and we want all the X's to be on one side of the equal sign, and we want all the 1s on the other side. So what I would do first, I would notice that I can subtract 2 X's from this side and subtract 2 X's from this side, like I'm matching them up. Okay, so that means I have no more X's left on mat B, and I have 4X minus 2X, which just gives you 2X. Don't forget the X, because a lot of people will see this and they'll just write the number 2, but you're bringing that X down because it's the same terms. We're combining them. Okay, now I'm going to bring 3 down because we didn't do anything to him yet, and I'm bringing 11 down because we didn't do anything to him yet. Okay, same thing. This is still mat A, and this is still mat B. So I can do some more matching. So I'm going to match 3 from this side. I'm going to take 3 away and match them up with 3 over here. I'm just taking them away. And that's okay because I'm doing it equally to both sides. So 11 minus 3 is 8. Bring down the 2X. 2X equals 8. Now, I want X all by itself. In order to get X all by itself, I need to do an operation here. Here's my original operation that I'm doing. 2 times X. This means 2 times X. It's just an invisible multiplication symbol right here. So in order to undo multiplication, we divide. Because I want to undo this. So we're going to divide by 2 to both sides, because it has to be equal to both sides. Okay, so 2 divided by 2 gives us 1, 1x, and I don't even write, I know a lot of us write like a 1 in front of the x, but you don't even need to do that, because it's like there's an invisible 1 in front of the x. Okay, and then 8 divided by 2 is 4. So, x, the number of games, would be 4, where this side would equal this side, and we need to double check how much money that would be. So I'm going to plug in my 4 to 4x plus 3. I'm going to do it over here to the side. So 4 times 4 plus 3, and that gives us 16 plus 3, which is $19. And if I want to double check the other one, I can do 2 times 4 plus 11, 8 plus 11, $19. So for C, there was a lot going on there. But it says how many games would the customer bowl? 4 games. And what was the price you would pay? $19. Okay. Moving on to D, and I'm making sure I don't want to erase anything important. Okay. Okay, so part D is asking. So the value of x we found in part C is called a solution to this equation. Okay, so that x equals 4 means it was a solution to those equations because it made this equal to this. This side equaled this side. Now we're going to figure out, is x equals 6 also a solution? I'm going to put a question mark. X equals 6 question mark. In order to figure this out, we have to plug in 6 for the x's that we have. So let's plug in 6. 4 times 6 plus 3, that's 24, plus 3, which gives us 27. So this side is 27. 2 times 6 plus 11, that's 12 plus 11, which gives you 23. So does this make the equation true? Does this side equal this side? No. So x equals 6 is not a solution. Exclamation point. All right, we have one more problem. 6-15. Solving for x. When the expressions on each side of the comparison mat are equal, they can be represented on a mat, and this is a new mat, called an equation mat. So it looks like this. It wants me to give you a resource page, but I can't do that, but I'll try to make that available in the Google Doc. It wants you to get algebra tiles, but if you're working online, you can use the e-tool for this one, but I'm going to draw it. So the double line in the middle means equals. Okay, so let's look at, it says part A, build the equation represented by the equation mat with algebra tiles or paper, or use the e-tool. I'm going to be doing it like if you were on paper. If you want to build it with the e-tool, that's fine. So let's see, we have, now I have to shade them in because we're dealing with positives and negatives, and I'll put the key up here. So the key is, oh, where'd the key go? That is a positive 1, and that equals negative 1. So the white cubes are negatives, the darkened cubes are positives. Okay, now I have an x, an x, an x. I'm just going to put x next to them because I don't have room for them inside. And then I have 1, 2, 3, 4, 5, 6. 1, 2, 4, 5, 6. And these are all positive cubes. I have 1 negative cube, and I have 1 positive x. Whew. So that's all part A is asking you to do, is build it. So either draw it, use your e-tool. We don't have any algebra tiles, unfortunately, but we don't really use them anyway in class. So for part B, on your paper, record the original equation. So now we're going to represent it with symbols, like variables and numbers. Okay, so this side, I see 3 positive x's, so that means 3x. And then I see 2 positive 1s, so I'm going to put plus 2. And I see 1 negative 1, so I'm going to put plus a negative 1. Okay, that's the first side. That means equals. I see 1 positive x over here. I see 6 positive 1s, so I'm going to put plus 6. And then I have 1 negative 1, so I'm going to add plus a negative 1. And I put the parentheses there to distinguish between the plus, the addition sign, and the negative symbol, so we don't get confused. Shouldn't be touching my face. Okay. Simplify. Oh, we did B. Okay, good. That's B. Okay, now part C says, simplify the tiles on the mat as much as possible. Record what is on the mat after each legal move as you simplify each expression. What value of x will make the expressions equal? So here's how I wrote mine down. And it looks like the first thing I did was I removed zeros from mat A and mat B. So I looked at mat A and I removed, I actually circled this pair and this pair. So that's a 0 and it can leave, bye-bye. And then on this side, I removed a +1, -1, and that can go bye-bye. So then I was left with, so here's what I did. I also put what I did. So remove zeros from mat A and B. That's my step 1. And my new equation after doing that is 3x plus 1 equals x plus 5. And hopefully I don't run out of room, but it looks like I might. The next thing I did, and you don't have to do it in this order, you might have done it differently, but I removed this, I matched this +1 with a +1 on this side, so I scratched it out. Uh-oh, something's wrong with my computer. Uh-oh. Okay. And I'm gonna put my step was I removed +1 from each side. Now my equation looks like, whoops, that's red. 3x equals x plus 4. And my last step, not my last step, almost last step. I matched up an x from each side. So I matched up this x with this x. So I remove x from each side, and I'm left with 2x equals 4, and I'm running out of room. My last step, your last step here, is to get x alone, and to get x alone, I want to divide each side by 2, because that will get x all by itself. 2 divided by 2 is 1, so I'm left with, sorry, I'm going to put this over here, x equals 4 divided by 2, which is 2. So, x equals 2 is our solution to this long equation, and I'm going to figure out what my laptop's doing. I don't know why it's doing that. I think I have a virus. Oh boy. Okay. Whew. Let me make sure everything's in frame. Yay! Everything's in frame. Alright, that is 6-50. Hopefully it wasn't too difficult to follow along. And I will get this up as soon as possible. Bye-bye.